This is just a short review of what we're trying to do with the bone grafting using artificial intelligence. AI is very good for image identification, so it solves problems like the Waldo problem very easily, and histological pictures are very complex. So we're using deep learning and convolutional neural networks to address this problem of identification. So having an understanding of how supervised learning works, where you establish your ground truth, can be helpful to you in understanding how artificial intelligence works and how convolutional neural networks work. So for example, to give an example in the bone histology, what you do is you outline a specific area and then identify in supervised learning what is in that area. For example, I've outlined an area where I think is live bone, and within that live bone is some bone graft. So I'm telling the artificial intelligence program what's live bone, what's graft bone, and then you make a second circle telling the program where to actually look. So everything within the black circle is what the artificial intelligence program is looking at. And you do this with a lot of histological images, so you give a lot of examples, and then you run a trial with thousands and thousands of iterations, and you test your program as it learns. This is called supervised learning, and eventually it identifies these patterns by looking at individual pixels. So it's a very interesting process. Here I'm outlining a collagenous tissue, live bone, graft bone, collagenous tissue, and fibrous connective tissue. It's done with different colors, and you do this by hand on many, many different tissues, samples, and the program learns after 20, 30,000 iterations of doing this. It eventually learns and has a very, very low error rate. The false positive, false negative rate should be under 2%. So this is the process of what you do. It's fairly labor intensive, and you do it on hundreds of images. I have hundreds of bone graft images, so I have plenty of images to actually look at and refine the algorithm that it eventually uses to read histological slides, and it can assess that slide. It can find Waldo in a matter of seconds instead of hours that it takes trained histopathologists to read these slides. So the promise is large, and the labor involved in it is considerable, but it's worthwhile. And these are just some of the other iterations that we saw, and it divides the scan up into little tiny areas. And this is the old way of doing it. You'd get these reports. Each of these reports costs about $600. And eventually what I'd like to do is train the program to read electron micrographs. So that's where we're going with this, and why I'm spending so much time trying to learn how these programs work.